So in this video, we're gonna gear up our computers for working with Python environment. We will go ahead and install the three packages or softwares that we need to work with Python. The first one is Python, the second one is Git Bash, and the third one is Visual Studio Code. So I'll just go ahead and open up my Google Chrome, and I'll search for python.org to open up Python's official website. I'll navigate to Downloads tab and I'll look for the latest version of Python, which is in my case Python 3.8.2. I'll click on that and I'll navigate through the page until I find the table named as Files. And in those files, I'll look for Windows x86 64 executable installer. And then I'll click on that. And my Python package is being downloaded. After that, I'll just go ahead and look for download Git Bash, and I'll click on the very first link, and after that I'll click on the option according to my operating system. In my case it is Windows, and I'll click on that, and my Git Bash for Windows will be downloaded soon. After that, I'll just go ahead and search for VS Code, which is Visual Studio Code, and I'll click on the first link, and I'll click on download for Windows because I'm using Windows operating system. And that's it. That's how I have downloaded all the three packages of software that I need for Python. So this is Git Bash, this is Python, and this is Visual Studio Code. So first of all, I'll just go ahead and install my Python package inside my computer. I'll double click on it to open up the installer. And before installing this package, I'll just go ahead and check the box add Python 3.8 to path, because if you don't do it now, you will have to do it afterwards, which might bring some errors. So after that, just click on install now, and your Python package will be installed in your computer successfully. Go ahead and hit close, and after that I'll just install my Visual Studio Code in my computer. I'll click on next, I'll click on next again, and here I will go ahead and check the first three options, and I'll also make sure that add to path option is also checked. So I'll click next, and I'll hit install button to install Visual Studio Code inside my computer. So I'll uncheck the launch Visual Studio option here because I don't want to open up my Visual Studio Code right now. And after that, I'll click on finish and double click on Git Bash setup and click on next again. And because I had Git Bash installed on my computer already, so that's why it's showing me this. Just ignore this and click on yes. And after that, just go ahead and click on additional icons so that you get an icon on your desktop. Here, just go ahead and navigate to use Visual Studio Code as Git's default editor. Select this option and click on next. And here, go to the third option, use Git and optional Unix tools for the command prompt. Click next, and after that you have to click next, 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 and that's how your Git Bash is going to be installed too. So that's how I have installed all of three packages or softwares in my computer, and I'll open up my Visual Studio Code to show you that how its interface looks like. This is my Visual Studio Code. This is the front page of the Visual Studio Code that we'll use, and after that I'll open up the Git Bash, and this is the terminal that I have installed named as Git Bash. And the third thing was the Python package, and I'll open up Python, and this is the Python shell that we'll use in our upcoming videos. So the very first thing that we want to do is integrate our Python and Git Bash terminal inside of our Visual Studio Code. in order to complete our Python development environment. So for that, I have to fire up my VS Code and install the appropriate extension for Python to integrate it with my Visual Studio Code. So this is the main interface that you're gonna see whenever you open up your VS Code editor. This right here is the terminal region where you can type in your commands to do certain tasks and achieve specific goals. And right here you will open up your files and edit your programs, whether they are written in HTML, JavaScript, or Python. On the very left side, you can see these 5 options as Explorer, Search, Source Control, Run, and Extension. You want to click on this option and you can see a search bar right here. Just go ahead and type out Python and it will show you a couple of items right here listed below in that search bar. You want to click on this item which is offering us a Python extension sponsored by Microsoft. Click on that. And now you're going to want to install this Python package by clicking on this install button. So it's going to take some time depending upon the processing speed of your laptop and as well as the speed of your internet connection. As you can see that it has already been installed in my Visual Studio Code. Now if you can see in this terminal tab, if you can click on this drop down menu, you will find this PowerShell written right here, which comes built in with Microsoft Windows. What I want to do is integrate or replace this PowerShell with my Git Bash terminal. So for that, I'll just fire up my Chrome and I'll type out integrate VS Code with Git Bash. So the very first link, that is from code.visualstudio.com. Click on that and navigate through the page until you find this field under Windows. Here you can see it's written Windows right here. Just go ahead and copy the line written under Git Bash. Copy this line. Now return back to your VS Code. Click on this file button, go to preferences and click on this settings. So this is the main settings area where you can control the visuals of your code editor like fonts, color and size and a couple of other things. But what you want to do is click on this button on the upper right side of your settings area. Click on this button and it will take you to this page right here. Now don't worry if you don't have written these lines already in your JSON file. Just go ahead and paste the line that you just copied from your Google Chrome here. Now if you have written some of your lines already, just go ahead and type a comma at the end of this line. And if you don't have written anything at all, you don't have to put this comma at the end of this line. The next step is hit Ctrl+S to save this file. And what we will do, we'll just go ahead and restart our VS Code. Now if you can notice in the terminal tab, if you click on this drop down menu, you can see that the PowerShell has been overwritten by this bash, and the text that was written here before has been replaced by the text written in this green and purple color, which means that we have integrated our bash terminal successfully in our code editor. At this point, we have successfully integrated our Python package and Git Bash terminal with our VS Code, which was the sole goal of this video. But why we are going to use our Git Bash instead of simple PowerShell? The answer to this question will be covered in our upcoming lectures. Thank you for watching this video. So the second lecture of chapter 1 is all about communicating with Python, which means that in this lecture we will go ahead and see that the installation that we did in the previous video was done correctly or not. We will run and test our Python by several commands and check its functionality to see that if our Python is working correctly or not. So this is the first command that we can try to interact with Python itself, which we usually use to see the Python version that we just installed in our operating system. And then we can also move ahead and try some of the functions and operations to see whether the Python is listening and returning the results correctly or not. So let's just move towards the practical demonstration of what I have just discussed with you. I will power up my VS Code because this is the same code editor that we installed to work with Python. So this lecture will mainly interact with the terminal aspect of VS Code. We will type our command, which was Python, to see if our Python was installed correctly or not. If the Python was installed correctly, after executing this command, the terminal will give us the version of Python. So I'll just go ahead and hit enter. And you can see that it just returned this value, which is showing us that Python 3.8.2 is installed in our VS Code. So which means that the Python is installed correctly in our operating system. We will also move ahead and perform certain operations to see if the Python is operating correctly or not. So let's just go ahead and suppose a variable x and assign a value to it. Hit enter. Now this command actually shows us that the x is a variable which has the value of 20. So if we want to print our x variable, it should return the value of 20. So what I'll do, I'll hit enter, and you can see that it just returned us the value 20, which we stored in this variable. We can also perform several tasks like we want to print x plus 50, which means that we want to add the 50 in the value of x, which is 20. So the answer should be 70. I'll hit enter and we get the answer of 70. This particular lecture was all about figuring out whether the Python was installed correctly or not. Thanks for watching this video. In lecture 3 of chapter 1, we will discuss that how we can run our Python programs. In other words, we will see that how many ways there are in which we can execute our Python programs. Well, there are two ways to run a Python program. The first one is interactive way and the second one is as a script. The interactive Python is good for a program of 2 to 4 lines of code. In other words, if you don't require a very long and complex functionality, and you don't have to write long sequence of logics, then interactive way might be good for you. But program of complex and long functionality requires a separate file consisting of number of lines of code. And after creating that separate file, we tell Python to run that file. We add .py at the end of the file name to indicate them as Python files. So I'll just go ahead and show you the practical demonstration of what I have just discussed here. I will open up my VS Code and first I will discuss the interactive way. So for example, I only have to add 2 or more than 2 numbers, and then I want to print out the results that I get after adding them. So this program does not require large number of code lines. So I'll just go ahead and use the interactive way to perform this task. I'll type Python and I will assign the values to multiple variables. For example, x is equal to 20, y is equal to 30, and z is equal to 40. And what I want to do, I want to add all of these numbers with each other. Now what I want to do, I want to add all of these numbers. Suppose another variable, and I will store the value which I will get after adding all these numbers, which will be x plus y plus z. Now in the next step, I'll go ahead and try to print out the value of this variable. And this is the answer that I will get after adding all these three numbers. So this is the interactive way in which we can use our shell to execute very small number of lines of code. Now we will move ahead and we will create a separate file for Python which we can use as a script, which will describe the running of Python programs as a script. So what I'll do, I'll exit from here and I will create a file named as script.py. Now this .py specifies the file as Python file. I'll hit enter and a separate file named as script.py has been created here. We will just go ahead and write Python as a script. So I will use the same example that I have discussed in interactive way. I will assign the values to three different variables. And after that, I will suppose another variable named as sum, or it can also be used as add, is equal to, and I will add all of these three variables. And after that, I will just go ahead and print this variable. I will hit Ctrl plus S to save this file, and I will type here clear and hit enter to clear this terminal. And after that, I will execute this file which was named as script.py. Now this is the Python that we installed in our operating system, and through this command we are telling this Python to run this file which is named as script.py. I will hit enter and you can see that the result has been printed out here. So this is the way in which we can execute Python programs as a script. In the future lectures, we will discuss more complex and long Python programs which must be written as a script. Lecture 4 of Chapter 1 mainly deals with the number of ways in which we can structure our Python programs. There are three different ways in which we can structure our Python programs. The first one is sequential structure, which follows the sequential steps. The second one is conditional structure, which have to follow the conditional steps. And the third one is repeated structure, which have to follow repeated steps. Now the sequential steps means that sequence of steps to be done in order, which means that every step of the program will be done after another step until it reaches to the endpoint. Conditional steps may be skipped on the basis of the condition, and the group of steps to be repeated belongs to repeated steps, which means that there will be a block of code which will be repeated again and again until it satisfies a certain condition. Sometimes we store a set of steps to be used over and over again as needed at several places throughout the program, which will be discussed deeply in chapter number 4. Now looking deeply into the sequential steps. In sequential steps, the program flows from one step to another step. Now for example, in the first step, x will take an input. There will be a value that we will assign to the variable x. In the next step, that value which was stored in x will be multiplied by 2. And after that step, we will print out the result. This type of coding is called sequential scripting. Conditional steps mainly depend upon the condition that we define in them. Now, for example, we have assigned a value of 6 in variable x. Now, if x is less than 5, then it will print out lower. But if x will be greater than 5, it will skip the lower part and then it will print out the bigger. And after that, it will follow a sequential step and print out close. In our case, x is greater than 5 because we assigned the value of x as 6. So it will print out bigger. And after that, it will print out close. In repeated steps, the program will run again and again until x becomes 0. And by x becoming 0, I mean to say that until it satisfies a certain condition that we define in our program. For example, we have assigned the value of 5 to variable x. Until the value of x is greater than 0, it will follow the path on the right side. It will print out the value, and in the next step it will decrease the value by 1. And then it will again check the value. If the value is again greater than 0, it will again go to the right side and print out the value, and it will again minus 1 from it. And then it will again check the value whether it is greater than 0 or not. Now if the value is equals to or less than 0, then it will no longer go to the right side. Instead, it will follow the path of left side, and then it will print out close. These repeated steps are known as loops in Python. Lecture 5 of Chapter 1 deals with the variables and reserved words in Python. So variables are the words in which the values can be stored. For example, x is equal to 30. Here 30 is the value or constant that is stored in x. So x is called the variable, and this right here is an assignment statement. The next example is x is equal to x plus 2. Here equals shows the assignment, and plus is an operator, and the meaning of this statement is add 2 in the value of x and restore that value in the variable x, which means that after addition, the value of x will be updated and the previous value will be overwritten. The next line is print x. This is a print function, and it is commonly used to print the values that are stored in variables. In Python, we have several reserved words for different functionality. Those reserved words can't be used as variable names. For example, false, class, return, none, if, for, true, def, and couple other more. In Python programming, all of these reserved words are used for specific tasks. For example, if is always used for conditional statements. We use for to write for loops. That's why these words cannot be used as variable names, because Python will not be able to differentiate these reserved words from variables. We will discuss the variables in detail in chapter number 2. Welcome to the lecture 1 of chapter number 2. In this lecture, we will discuss the differences between variables and constants. In other words, in this chapter, we are going to look deeper inside the variables. And to understand the concept of variables, we have to understand the difference between variables and constants. First of all, let's look at the constants. Fixed values such as numbers, letters, and strings are called constants. They are called constants because their values cannot change. There are two types of constants. The first one is numeric constants and the second one is string constants. Numeric constants can only contain numbers. These numbers can be of any type. They can contain decimal points in them, they can be in fraction, or they can be simply any real number. On the other hand, the string constants can only contain alphabetic characters or letters or words in them. For example, in string constant, we have written hello world. Now these are the alphabetic words that are stored as a constant. So this will be called string constant. Earlier we discussed that the constant are the values which cannot change. Variables are the words or names which contain or store those constants that we have discussed earlier. A variable is a named place in the memory where a programmer stored data and later retrieve the data using variable's name. Programmers can choose the name of the variable, which means that we can assign any name to the variable. Unlike constants, the value of the variable can be changed. For example, here I have taken a variable named as my variable, and I will assign a value of my name is John to that variable. Now after assigning that constant to my variable, I have allotted a place named as my variable in the memory of my computer, and in that memory I have stored a value which is my name is John. Now during writing a program I can recall that variable, and whenever I will recall that variable, that means I am calling its value, which is my name is John. Now we said that the values of variables can be changed. If you can see in the example, in the next line I have assigned the different value which is 94 to the same variable. And now if I will go ahead and try to print out that my variable, the answer will be 94 instead of my name is John. Because in the next line I changed the value from my name is John to 94. And after doing that, my name is John is overwritten by 94. And now my variable has a value of 94 in it. In Python, reserved words can't be used for a variable name. Reserved words are the words that are already used in the Python library for specific tasks. That is why whenever we will use those reserved words as a variable name, the Python will not be able to differentiate whether this is a reserved word or a variable. That is why the best practice is to avoid using reserved words as variables. Some of the reserved words examples are given here. In this lecture, we are going to discuss the rules that we have to follow to name our variables. The very first rule that we have to follow is that our variable name must start with a letter or an underscore, which means that our variable name cannot start with a numeric character or a special character. The second rule is our variable name must consist of letters, numbers, and underscores. It should not have any special character at any point. The variable names are always case sensitive, which means that if you write a variable name in capital letters and you write the same variable name in small letters, both of these variable names will be different, and hence the corresponding variables will be different from each other. The good practice of writing variable names is given here. We can write our variable names just using letters and words. We can also write our variable names and use numeric characters at the middle or at the end of the variable name. And we can also add underscores in our variable name. We should never start our variable name with a numeric character or a special character. Also, we should never use a reserved word as a variable name. Now look here, all of these four variable names are different from each other. Because remember we have discussed that variable names are always case sensitive. Here the first variable name is written in small letters, but the second variable name contains F in capitals, which make both of these variable names different from each other. Since we can choose the variable names, so there is always an opportunity of best practice. Try to give names to the variables which help us in remembering the data. And giving such variable names to our data is known as mnemonic variable names. Now, variable names can get confused when writing longer scripts. For example, if you give random names to your constants and after that you go ahead and write longer scripts, at any point in your program you can get confused one variable with another. But if you use mnemonic variable name format, the chances of getting confused reduce to very low level. For example, look at here. In the first case, we have given the random names to our constants. But in the second case, to the string my name is John, we have assigned a variable name which is also named as name. And we have assigned 40, which is age of a person, as a variable name age. Now, no matter how long our script gets, we will always know that in the name variable we have stored the name of a person, and in the age variable we have stored his age. So this practice is called mnemonic variable name format. In this lecture, we are going to discuss assignment statements in Python. We will understand that what are assignment statements and how we can write these statements in Python program. But first of all, let's recall our variables. Variables are the words in which the values can be stored. For example, here the value of 30 is being assigned to the letter X. This whole statement is an assignment statement because here we are assigning the value to a variable. Now look at the next line. Here X is equal to X plus 2. On the right hand side, we have an expression which is X plus 2. And on the left hand side, we have a variable which is also X. And we are assigning the value of X plus 2 to the variable X. So this line shows assignment with expression. In the next line, we have print parenthesis X. This is the print function, which is used to print the value of that variable X. Whenever we assign a value to a variable, we use an assignment sign which is equals. An assignment sign consists of an expression on the right hand side of the equals and a variable to store the result. For example, X plus 10 is an expression, and on the left hand side of the equal is a variable. So whatever the result of X plus 10 will be, it is going to be stored in the variable X, which is on the left hand side of the equal. I am John is the string constant which will be stored in the variable name. And this expression 5.1 multiplied by X divided by 10 raised to power 2, all of this expression and its result is going to be stored in the variable X. Now let's look at the more example of assignment statements. Here on the left hand side, X is the variable to store the result of X plus 10. Name is a variable in which I am John is stored, and it can be recalled whenever we need them. Look at this example. Here y is equals to 5.1 multiplied by X divided by 10 raised to power 2. Here y is the variable which can also be referred as memory location, in which the answer of the whole expression, which is 1.275, is stored and can be recalled wherever we need it. Now let's suppose these two operations are written in the same program. In the first case, y has the result of 1.275, but in the second case, y has the result of 0.0829, which can also be referred as new value. This new value will be updated in the same variable y, and it will replace the old value, which is 1.275, because y is the variable and variable are the words which can change their value. Remember, everything on the right hand side of the equal is an expression. When we'll use Python, we will often have to deal with the mathematical expressions. And in order to solve those mathematical expressions, we will have to use numeric operators. So in this lecture, we are going to discuss the numeric operators in detail. Mathematical operators in computer language are a bit different than classical mathematical symbols. The purpose of those operators will be exactly the same, but the symbols through which we will show those operators will be different. For example, for addition, we will use plus, which is same as the classical mathematical symbol of addition. But for multiplication, we will use steric. For division, we will use slash. For power, we will use double steric. And for remainder, we will use percentage sign. Here are some of the examples of numeric expressions which are using numeric operators. In the first example, we are doing addition. In the first example, we are doing addition using plus operator. In the second example, we are doing multiplication by using steric operator. In the third example, we are doing division using slash operator. And in the fourth example, we are finding remainder using percentage operator. Here it is very important to understand the difference between division and remainder, which is also known as modulus. Now suppose you are dividing 16 over 2. When you will multiply 2 with 8, you get 16. And when you will subtract the 16 from 16, you get 0. That 0 is the answer of remainder, and that 8 is the answer of division. So that is the main difference between division and remainder. In this lecture, we are going to discuss the order of evaluation when we use numeric operators in our Python program. When we use string operators together, in other words, using multiple operators in a same line, then Python must know which one to do first. This is called operator precedence. For example, here we have a numerical expression in which multiple numeric operators are being used in a same line. So Python have to know that which part of the expression it has to solve first in order to get to the answer. This problem is solved by the order of evaluation. So the order of evaluation is as follows. In the first step, parenthesis will be solved in the expression. After that, exponent will come next. After solving exponents, multiplication, division and remainder will be done. And after that, addition and subtraction will be solved. And all of these operations will be done from left to right. Always remember this order. Parenthesis will be solved first. Exponent will be solved in the second place. Multiplication, division and remainder comes after solving the exponent. And in the end, addition and subtraction is done. For example, here we have an expression 2 plus 3 raised to power 5 by 5 minus 1. So in this expression, we have to solve the exponent at the first step. 3 raised to power 5, which is 243. After, as you know, multiplication or division or remainder comes. Here we have division, so the division will be done. 243 by 5, which comes as 48. After that, addition and subtraction is done. So start from the left. 2 plus 48 is 50. And 50 minus 1 is 49. And this is how Python solves our expressions which has multiple numeric operators in a same line. Now let's see the practical demonstration of order of evaluation. So we will open up our Python shell and I will assign the expression 3 raised to power 5 divided by 5 minus 1. And I will assign all of this expression to a variable called x, which means that the answer of this expression will be stored in the variable x. I'll go ahead and press enter. And after that, I will try to print out my variable x. And now you can see that it has printed out the answer of 49. Now let's see the step-by-step process to verify that the order we just studied was correct or not. So according to the order of evaluation, this expression term has to be solved first. So we'll go ahead and find the answer of this part, which is 243. In the next step, 243 should be divided by 5. So let's just divide 243 divided by 5. And the answer is 48. After that, 2 should be added into 48. And the answer is 50. And after that, 50 minus 1. And the answer is 49. So the order of evaluation is verified through this example. In this lecture, we are going to learn about comments in Python. We will discuss that, what are comments and why do we use them in any programming language. First of all, let's just see how we can write a comment in a Python programming language. Hashtag is used to write a comment in Python programming. But why do we need comments? There are two main reasons behind writing comments in Python. The first one is describing what is going to happen in a sequence of code. And the second is turning off the line of code, maybe for debugging purposes. For example, here I have an assignment statement. X is equal to my name is Talha. And in front of that, there is a comment which states this line stores my name is Talha. Here this comment is actually describing what is going on in the line of code. And to see how we use these comments for debugging purposes, let's move towards the practical demonstration. Here is an example through which we can understand that how we can use these comments to describe our line of code. And also that how we can use these comments for debugging purposes. Now if you look at this line, you can see that it is starting from a hashtag. And unlike other lines, it is green. That is how we write comments in our Python program. Now this line is stating that value 45 is being assigned to variable x. Now if you look at this line, that's what is actually happening here. The value 45 is being assigned to a variable x. And if you look at this line, it is stating that this line prints the value of z. And that is what is actually happening here. Print function is used to print the value, and in the parentheses there is z. So obviously the print function is trying to print the value of z. So in this way we can use these comments to describe our line of code. Now for example, I go ahead and remove this hashtag to enable this line, and I save this file and I try to run it. You can see that instead of giving me the value of z, it actually showed me the error. So what if I move ahead here and put a hashtag here? As soon as I put a hash at the beginning of this line, it becomes green too. It means that this line has been converted to a comment, and because it is a comment, it is no longer enabled. Now what if I just go ahead and hit Ctrl+S to save this file again? And after that, what if I try to run this file again? You can see that this time it didn't show me any error. Instead, it gave me the answer, which is the answer of x plus y. So you can see that in this way, we can disable or turn off lines of code by using comments. And that is how we use these comments for debugging purposes. Up till this point, we have enough knowledge of Python to make a proper program. So in this lecture, we are going to make a very simple Python program. Sometimes we need to convert the user input to use for backend procedure. For example, what if I wanted to take the input from a user in runtime, and after that I want to add 1 into that number, and after that I want to print out the result of it. So adding 1 and printing out that result is the backend procedure. We use input function to take input from the user in runtime. But there's one thing that you always have to remember. The data which you take by using input function is always in string, which means that whatever value that will be stored in the variable x is a string, and hence 1 can be added in the string because 1 is an integer. So we have to convert that string into an integer. For that purpose, we use another function called int. Int function is used to convert the string data type into integer. And the correct syntax is writing the variable that we want to convert into the parentheses of int function. Now let's move to the practical demonstration of what we have just discussed here. So our task was that we have to take the input from a user in runtime. So I will suppose a variable in which the value will be stored is equal to, which is an assignment operator, and after that I will write input. This is the function that will take the input from user, and inside this parenthesis I will write enter your number. It is the string that the user is going to see whenever he runs the program. After that, this input function fetches the data that the user enters into the terminal. And after that, that data will be stored in this variable x. In the next step, we wanted to add 1 into our number. So let's suppose another variable y is equal to x plus 1. Because x is the variable where the input from the user is stored. And after that, I want to print out this variable. Now I will save this file by Ctrl+S, and I will try to run this file using Python and name of this file. So this is the line that the user was going to see, and this time I am the user. So I'll just go ahead and type out 23 and hit enter. Now you can see that instead of giving me the answer, it showed me an error, because whatever value is stored in this x is in string, and we are adding an integer in that string. In order to solve this problem, we have to convert this string into an integer, and we will use a function called int, and we will write this variable into the parentheses of this function. Now I will again save this file, and I will again try to run this file. It is asking me for the number again. I will type out my number 23 and hit enter. And now you can see that it gave me the correct answer, which is 24. So congratulations, you just made your first proper Python program. In the future lectures, we are going to make complex and long functionality Python programs too. In the last section of this chapter, we have a Python program to make to strengthen our concepts of what we have learned so far. Write a program that takes number of kgs and price of rice per kg as an input from the user, and then calculates the cost of total number of kgs. So here we have to take 2 inputs from the user in runtime. The first one is number of kgs, and the second one is price of the rice per kg. After that, we have to do our calculations at the back end, which is also called backend procedure. And then we have to print out the result. So best of luck for this exercise. The question was, write a program that takes number of kgs and price of rice per kg as an input from the user, and then calculates the cost of total number of kgs. And I mentioned that here we have to take 2 inputs from the user. The first input is number of kgs, and the second input is price of rice per kg. So let's move ahead and solve this problem. Now first of all, I will go ahead and create a file named as exercise.py because this relates to the exercise. I'll hit enter and you can see that a file named as exercise.py has been created. So let's just write here exercise1. Now remember that I told you we have to take two inputs. So the first one can be stored in X and the second one can be stored in Y. To take the input, we have to use a function named as input. And in the parentheses, we write a string that the user will see when it runs the program. So the first input will be enter the number of kgs. And the second input will be enter the price per kg. So the first input will be stored in X and the second input will be stored in Y. After that, we have to calculate the cost of total kgs. So for that, I will suppose another variable and I will multiply number of kgs with cost per kg. That is how we can find the cost of total number of kgs. And after that, I have to move ahead and print out the value of z. But don't forget to convert your input strings into integers first, because this is an numeric operator and numerical operator only works for integers. So we will use int functions to convert our strings into integers. Now I will save this file by Ctrl+S and I will run this file using Python. I will hit enter. Now it is asking me number of kgs, so let's enter 3. Now it's asking me price per kg. Let's suppose the price is 40. Now it just gave me this answer here, 120, which we get by multiplying 3 with 40. Now let's just move ahead and make it more elegant. What we can do, we can write a string in the print, the cost of total number of kgs is, and after that we can write the variable in which the answer was stored. This is called concatenation. I'll hit Ctrl+S and I will rerun this file again. It is asking me for the number of kgs. I'll enter 4 and the price is 50 and the answer will be the cost of total number of kgs is 200, which we get by multiplying 50 with 4. Chapter 3 is all about conditional statements. But to understand that what those condition statements actually are, we need to understand the concept of comparison operators. In this lecture, we are going to move ahead and understand that what are comparison operators and how we can write them in Python. In Python, Boolean expressions ask a question and then return a yes or no answer, which is then used to control the flow of the program. This right here is known as comparison operator. Now the number on the right hand side of this operator is supposed to be bigger or larger than the number on the left hand side of this operator. Here we have a couple of other comparison operators, and on the right hand side we have the description corresponding to its comparison operator. For example, the first one we have less than operator. In the second position we have less than or equals to. In the next position we have equals to. Whenever we will write two equals together in Python, then that means that we are comparing two numbers and we are telling that the first number is equals to the other number. The next position we have greater than or equals to. In the next position we have greater than, and in the last we have not equals to. In future lectures, we will use all these operators in our examples to understand the use of these comparison operators. There is one thing that you need to understand is whenever we will use single equals, then that will mean that we are assigning a value to a variable. There's a slight difference between one equal and two equals writing together. The one equal will be used for assignment, but two equals written together will be used to compare two numbers. Here we have an example in which we will write conditional statements. We will use comparison operators, and then we will write the blocks of code for the corresponding condition. Now at the very start, we are assigning the value of 6 to the variable x. And in the next line, we are asking Python to check if x is less than 5. So here we are comparing our number 5 with our x, which has the value of 6. Now if x is smaller than 5, it will go ahead and print lower. But as you can know that the value of 6 is greater than 5, so it will not print out the lower part. Instead, it will move ahead to the next condition, which is defined as else if x is greater than 5. And if that's true, then go ahead and print bigger. And after that, get out of that conditional statement and then print close. So here we have used a Boolean expression to control the flow of our program. For the first part of the conditional step, the answer was no. So instead of printing lower, we moved to the other way, which was checking other condition. And when the second pass was true, then instead of checking any other condition, we move ahead and print it out bigger in our result. So here you can see different operators, and you can see what they are used for. Now x is equal to 5. Here equals is written single time. So this means that 5 is being assigned to the variable x. But in the next line, x is equals to 5, because here we have two equals together. In the next line, we have x is greater than 5, and then we have x is greater than and equals to 5, which means that the value of x starts from 5 and go all the way up. In the next line, we have x is less than 6. Here you can notice that the number on the right hand side of the comparison operator is the bigger number, and the number written on the corner side of the comparison operator is a smaller number, which means that the value of x is less than 6. And the same will be followed by the next condition, which is x is less than and equals to 7. In order to write the actual code for conditional statements, we have to understand the syntax of it. The concept of indentation in Python is really very important, because the slightest error in the indentations can lead up to very major problems, which might end up stopping the flow of the program. To understand the concept of indentation, I have taken the liberty of writing this very small example of conditional statements. In the first line, I have defined a condition using a comparison operator, which is x is less than and equals to 5, and at the end of this condition, I have added a colon. Now, as soon as I will hit the enter after that colon, the Python by default will add 4 spaces before the next line. As you can see that I have highlighted these 4 spaces using different colors. Now these spaces are known as indentations. In Python, we don't use any curly brackets to define the body of our condition or a loop. Instead, we go ahead and use these spaces to define the body of a certain condition. So right now, in this case, these 2 lines are the body of the first condition. And after these 2 lines, I have defined another condition, which is x is not equal to 10, and I have again added a colon at the end. Now as soon as I will hit the enter again, the Python will add spaces by default again. Whenever you add a colon in the statement, whether it is a loop or it is a conditional statement, the next line after that colon will have a certain amount of spaces before it. Those spaces are known as indentations. Here I have mentioned all the components of this program by using different colors. Orange color shows the condition, green color and the spaces are shown by indentations. The red color shows the body or the block of the if statement, and the gray color is reduced indentation, which means that this statement at the end is not the part of the previous condition, because in order to make it the part of the previous condition I had to add spaces. But in this line there is no space before the print, so it doesn't make it a body of the previous if condition. So this is known as reduced indentations, which also means that outside the if statement. Now there are multiple ways of using conditions. We can also use these conditions for one-way decisions, or we can also use these conditions for nested decisions. We will go ahead and see the video demonstration of what we have discussed here. So here we have an example in which we have these two conditional statements, and both of these conditions have the corresponding bodies for them, and this at the end we have a separate line. Now we will go ahead and understand that how Python actually differentiates between the body of the if condition and the statements that does not belong to any condition. So in the first line I have defined a condition here, which is x is less than and equals to 5. Now if this condition is satisfied, the Python code enters to the body of this program and prints out these two lines. But you can notice that after I have added this colon, in the next line, if I go ahead and select this space, you can see that here we have 4 dots, 1, 2, 3 and 4, which means that here Python has added 4 spaces before this line. These 4 spaces are known as indentations. Now after printing out this second line, the body of the first condition has been finished. The Python will exit this condition. Now for example, if this condition was not satisfied, the Python would have moved ahead to the second condition, which is x is not equals to 10. And again, after the colon, the Python has added these 4 spaces to define that the next 2 lines is the body of this condition. After entering this condition, the body will print out these 2 lines. Now for example, I go ahead and add another condition inside the first condition. So it would look like this. If x is less than 3, and you can see that this time the Python has added these 4 spaces in addition to the previous 4 spaces. And if we go ahead and write something here, this will be the body of this condition, and this condition is inside the body of this condition, which is the first condition. So that's how we structure our conditional statements in Python. And you can call this a child condition, and you can call this a parent condition, because this condition comes inside this condition. Now as soon as we enter to the next line here, you can see that there is no space before this line. It makes this condition a separate condition which is outside of this first condition, and the Python will work on the body of this condition independently. Now this structure right here is also known as nested conditions, because this first condition is present in the second condition, and you can call this as a nest of conditional statements. We have more conditional execution patterns, which means there are multiple types of patterns in which we can use our conditional statements. For example, in the first line, I have assigned a value of 4 to the variable x, and in the next line, I have defined a condition which shows x is less than 5. So for example, when this condition is satisfied, the program will move ahead into the body of this condition and print out small. And if this condition isn't satisfied, for example, the number that I assigned to the x was 6, which is greater than 5, then the first condition will be falsified and the program will look for another condition. So here we have this if-else structure in our conditional statements. If gives one way to run the program, and if that condition is not satisfied, then the program moves in the other direction, which is else. So for example, the number that I had assigned to the x was 6. In that case, the first portion of the condition will be falsified, and program will look for another condition, which is else, and program will go ahead into the body of this else and print out large. After printing out that large, it will move ahead to the next statement, which is outside the previous condition structure, and print out all done. We will use this visual block to understand what is actually going on. So at the very start, we had assigned the value of 4 to the variable x. After that, we have defined a condition which is x is less than 5. Now if the condition is satisfied, the program will move to the right side and it will print out small, and after that it will print out all done. But if somehow the condition isn't satisfied, the program will move towards left side and it will print out large, and after that it will print out all done. So here you can see that the conditional structure, the if-else structure, is shown in this control flow diagram. Let's have a look on another execution pattern, which we can also call a multiple conditional execution pattern. Now at the very start, I have again assigned the value of 4 to the variable x, and in the next line I have defined a condition which is x is less than 5, and at the end of this condition I have added a colon, and at the next line there is a certain amount of spaces before our print statement, which is actually called indentation. Now if the first condition is satisfied, the program will go ahead and print out small, and after that it will ignore all other conditions and move to the next statement, which is outside this if-else condition structure, and print out all done. But consider that first condition isn't satisfied. So after checking the first condition, the program will look for another condition, which is defined as else if, which in other words mean that if the first condition isn't satisfied, then go ahead and look for another condition, which is x is less than 10. Now if this condition is satisfied, the program will print out medium, and after that it will ignore all the coming conditions and print out all done. Now if the second condition is also falsified, the program will look for another condition, and this process will go on until it finds an appropriate condition or an output. We will try to see then what is actually going on in this program using our control flow chart. Now at the very start, I have assigned a value of 4 to the variable x. In the next line, I have defined a condition which is x is less than 5. Now if this condition is satisfied, the program will move to the yes direction and print out small, and simply it will move ahead and print out all done, ignoring all the other conditions in the program. But if the first statement isn't satisfied, the program will move towards the no direction and it will look for another conditional statement. Now here the second conditional statement is x is less than 10. Now if this condition is satisfied, the program will again move towards the yes direction and print out medium, and after that all done will be printed out. But if for some reason the condition isn't satisfied, for example the number is greater than 10, then the program will move towards the no direction and look for another conditional statement. In the third step, it will look for another condition which is x is less than 20. Now if your number which is stored in x is less than 20, then the program will move towards the yes direction and print out large, and after that it will ignore next condition and print out all done. But if the condition isn't satisfied, the program will go towards no direction and print very large, and after that it will go ahead and print out all done. So this is how multi-way conditional patterns actually work in Python programming. Here we can also see the examples of indentation. We can see that the certain amount of spaces are being used to define the body of every condition. In addition to if-else structure in conditional statements, we also have another structure which is called try and except format. We will look deeper inside this try and except structure, and we'll try to figure out what are the benefits that we can get from this structure. Now simply, if the code which is present in the body of the first condition, which is try, works, then except is skipped. But if the code of the body in try fails, then it ignores the try code and jumps to the except section. Now it seems exactly same as if-else structure, except it isn't. In if-else structure, Python looks for the condition, and if the condition is satisfied, then the body of the condition is executed, and it ignores every other condition in the program. In if-else structure, the Python judges the condition, but in try and except structure, the Python judges the body of the condition. If the code in the body of try works, then it ignores the other condition. But if the body of the first condition fails, then it has to execute the second condition, which is except. We will try to understand the use of try and except code by using an example. What if the program gets a string from the user as input instead of an integer? Now we all know that input function takes the input from the user in runtime and saves that input in a string format. And afterwards, we have to convert that string into integer, which you can see y is equal to int parenthesis x is doing that. But what if the user enters 5 in word instead of writing 5 in number? Then the second line, y is equal to int parenthesis x, will show error because the string cannot be converted into an integer. And that's when try and except structure comes into action. Now, for example, the input that the user entered was 112 in string. Now, what we will do, we will write a program using try and except conditions. First, we will write try, which is y is equal to int parenthesis x. In this line, we will try to convert our input into integer. Now, if this code works, the program will ignore except. But as we know that int function cannot convert string into integer, so this line of code will not work. And the program will move to the except section. And in that section, -1 will be assigned to the variable y. And after that, we will go ahead and print out the result is y, which is -1. Now on the right hand side, there is another example in which the user actually entered numbers. In this case, the code inside try will work and the string will be converted into integers. So the program will ignore the except section and print out the result is y, and the output will be the result is 112. That is how we can handle this string and integer problem gracefully using try and except structure. At the end of this section, we will move ahead and perform exercise to understand the try and except structure properly. So this is the exercise that we're going to perform, and the statement says that rewrite your pay computation program to give employees their pay based on the number of hours they worked if the rate per hour is 40. Use try and except structure to handle the non-numeric input gracefully. So what we have to do, we have to ask the user to enter their input in the runtime, and then we have to compute their pay, and then we have to print out their pay. But this time we have to use try and except structure, because what if the user give input using words instead of numerical values? In that case, we will have to use try and except structure to handle that non-numeric input gracefully. We have to solve this exercise using try and except structure. What we have to do, we have to ask our users to enter their input in runtime. They should enter their number of hours and they should enter the rate per hour, and then the program should calculate their pay and show their pay as a result. The program should also solve the problem of non-numeric inputs. So this is my Visual Studio Code where I will create a Python file and I will code my program. First of all, I'll move to the directory where I want to save my file, which is desktop, and I will move further to this folder which is called Udemy Python course, which I made certainly for the course, and inside of that folder I have to go to the chapter number 3 folder. And inside this chapter number 3, I have to go into 6th lecture, which is try except structure solution. And now we are in this folder right here. And here I will go ahead and create a file named as exercise_2.py. And you can see that a file named as exercise_.py has been created here. I will go ahead and clear out this terminal. And I will write a comment here. Exercise to try and accept structure. Now, what we had to do, we had to ask our users to enter their inputs. So the first input that they should enter is the number of hours that they have worked for. And in the second input, they should enter the rate per hour. So we have to define two variables. The first one is x and the second one is y. In x variable, we will try to enter our number of hours. So we will write enter hours. This string will be shown to the user when the program will run, and this function input will take the input from the user in runtime and store that value in this variable x. We will do the same for y. We will use input function, and here this time we will ask for enter rate. Now we know that anything this input function will capture will be stored in string. So we have to convert the string into an integer. But what if the user has entered an input in words? So in order to solve this problem, we will use try and except structure. Here you can see that I have written my condition try, and at the end I have added a colon, and as soon as I will hit the enter, a certain number of spaces will be entered in the next line. Here I will try to convert my string value, which is stored in x, into an integer. So I will write int x. This function int will convert this string into integer, and I will try to store this integer value into another variable which is called z. And I will do the same for y, int y. Now if this code works and both of the values are converted into integers from string, then I will simply just go ahead and define another variable, and I can calculate the pay by multiplying the number of hours with rate, which is d. Initially, we stored number of hours in x and rate in y, but after converting this string into an integer, we stored the value into z and we stored the value of y into d. So in order to calculate our pay, we have to multiply z with d. And after that, I can just go ahead and print out the value pay. And here I will write the variable. Now let's just go ahead and define the second part of the condition, which is except. I will write except and add a colon at the end, and after that I will hit enter. And here I will just go ahead and I will write z is equal to -1 and d is equal to -1. And after that I will print out a string which is error, only numeric values can be added. Now let's just see how this code will actually work. First of all, the Python will try to run this program. It will try to convert the value of x from string into integer, and it will also try to convert the value of y from string to integer. And if that works, it will multiply both of these variables to calculate pay. And in the next line, it will print out the pay for users to see it. But if for some reason all of this code doesn't work out, what if the user entered the input in words instead of in numbers? Then these two lines will not run. In that case, the program will skip this part and then it will jump to the except portion. And if the values are not converted into integers, then the z will be equal to -1 and d will also be equal to -1. In that case, the program will print out error, only numeric values can be added. So we will just go ahead and save this file and we will try to run this file using Python. I will hit enter and it is asking me to enter the number of hours. For example, I worked for 23 hours. And in the next step, it is asking me for the rate per hour. For example, the rate is 2. So in the next line, it is showing me pay, which is 46. Now, what if I rerun this program again? I enter my number of hours as 23. And this time, I enter the rate 2, which is in words. And when I will hit enter, it is showing me that error, only numeric values can be added. So this is how we can use our try and except structure to handle non-numeric values gracefully. Chapter 4 mainly deals with the functions in Python. We will have an overview that what are functions and how we can use them in our Python programming. First of all, we have to understand that how many types of the function there are in Python. Well, there are two kinds of functions in Python programming. The first one is built-in functions, and the second one is functions that we define ourselves. Now, built-in functions are the functions that are given as a part of Python through its libraries. For example, print, input, float, int, and so on and so forth. All these functions are already written inside of Python libraries, and we only have to call these functions to perform specific tasks. For example, print function printouts everything that is written inside the parentheses. An input function is used to grab the input from the user. Now let's come towards the second type of functions in Python. The functions that we define ourselves and then reuse them over and over again. For example, here I am defining a function named as test. To do that, I'll just have to write def, which is a reserved word to define a function. So I'll write def test parentheses and colon. And after that, I will hit enter. And Python will add certain amount of spaces before the next line. Those spaces are called indentations. Now everything that will be written next is the body of that function. Now for example, here print I am a function is the body of the function test. I'll just go ahead and write the remaining part of the program. I'll write x is equal to 4, which means that I'll assign the value 4 to the variable x. In the next line, I will say the value of x plus 6 in the variable y. And in the next line, I'm just going ahead to print out the value of y. And after that, I'm recalling that function that I just defined previously, which is test. So when I will just go ahead and try to execute this program, the output will be like this. 10, I am a function. Now 10 is the answer of y, which was x plus 6. And after that, I just called the function that I defined previously, which was test. Now after calling that function, everything written inside that function will be executed, which is in our case is a single line of code, print I am a function. Now when this line will be executed, I am a function will be printed out in the output. Now that is how function actually work in a Python. Here print is a built-in function and test is the function that is defined by us. Now we'll see that how we can define a function. In Python, a function is a block of code which takes some input as an argument and do some computation and then returns a result. We define a function using def reserved word. As the function can be reused, we can call that function again and again at any part of the program. We call the function by using the function name and parentheses and an argument in an expression. For example, here def is used to define a function, and add is the name of that function, and a and b are the arguments. Now whenever you will call this function, it will take two variables, use them as an argument, and then add them, and then it will print out the value. We will just go ahead and see the video demonstration to understand functions in detail. In the video demonstration, we will go ahead and understand that how we can define a function and how we can execute that function in Python. So for that, we'll just go ahead and open up our Visual Studio Code. Now first of all, what I'll do, I'll just go ahead and define a function named as test. Def is used to define this function, which has name of test. After this statement, I will put a colon at the end and I will hit enter. And as soon as I'll hit the enter, the Python will add certain amount of spaces by default. These spaces are called indentation. Now everything that I will write after these spaces will be the body of this function. Suppose I have written this line inside of this function test. So this line right here is the body of function test. Now after that, I'll just go ahead and write the remaining part of the program. For example, I take a variable x and I try to put a value of 4 inside it. After that, I take another variable and store the value of x plus 6 in it. Now the value of x was 4. So 4 plus 6 should be 10. In the next line, I will try to print out the value of y. Now after this line, what I am going to do is calling the function that I just defined previously. Now what will happen in the output, I will see the value of y, and after that I should see the value of everything that is inside the function test. So I'll just go ahead and save this file and I'll try to execute this file using Python. You can see that in the result we can see 10, which is the value of y, and after that in the next line im function is printed out. Now this im function actually came from this test function, because in the test function we try to print out im function. So whenever you will call this function, everything inside this function will be executed. So let's just level up our use of functions. I'll comment out this to disable everything that I've written in this function, and in the next line I will define a new function named as add, and in the parentheses this time I will write elements. These elements are known as arguments of this function. At the end of this statement I will put a colon and I will press enter. Now I have to define the body of this function. So for example, I'll take a variable c and I will put the value of a plus b in it, and then I will try to print out the value of c. The value of c is, and I'll write the variable name c. This part of the code will remain same, but here instead of calling test, I will call add. I will assign the arguments to this function too, which are x, y. Now when the program will call this function, it will also provide this function some values. The value of x will be stored in a, and the value of y will be stored in b. And after that, everything that is inside this function will be executed. So I'll just save this file and I will try to execute this file. Now you can see that in the first line we have 10, which is the value of y, and after that we called our function add, which was supposed to add these two values. The value of x is 4 and the value of y is 10. So 4 plus 10 should be 14. And you can see that the value of C is 14. So that's how we can execute and define our functions in Python. Functions can also be used for data type conversions. We can use built-in functions to find and manipulate the type of data. For example, here I have assigned the value of 6 to a variable x. I can use a built-in function called type to find the data type of x. As soon as I will put the variable in the parentheses of this built-in function and hit enter, it will return the result as class int, which shows that the value of x is actually an integer. In the next example, I will store value of 7.0 in variable x, and after that I will go ahead and check the type of the data. Now as a result, it will return the class of float, because whenever you put a floating point in an integer, the integer becomes float. So that is why the class changed from int to float. In the third example, I will store a string in a variable. Now on checking the type of that variable, I will get the class string, which shows that the value of x is actually a string. We can use built-in functions for type conversions. For example, here I have stored a value of 6 in the variable x, but this time I have stored this value using inverted commas, which means that this is a string. Now on checking the type of the data, as a result I will receive the class name string, but I can change the data type of x using a function called int. Now I will put that x inside the int function, and after that I will find the type of the new variable y, and this time as a result I will get a class of int, because int function just changed the data type of x from string to integer. In the third example, I am using the exact same variable which has the value 6 as string, and this time I am putting that x inside a float function, and I will store the value of this float function in variable y. Now after finding the type of the y, I will get a class of float, because the float function has changed the data type of x from string to float. We are controlling the data type with built-in functions. If the string has numeric characters, for example, x is equal to 1, 2, 3, 4, 5, 6, 7, but all these numbers are written in inverted commas, so that makes them a string. Now if you will check the type of the data using type function, the type will be string, and in the next step what I'll do, I will put that x in which I stored my numeric characters into an integer function. I will store the value of that integer into a new variable y, and this time I will find the type of this new variable y, and as a result I will get the type as int, which means that we have converted our data type from string to integer using int function. But what if the string has non-numeric characters? For example, here I have stored this string I am a non-numeric string inside of variable x. Now on checking the data type, as a result I will receive the data type as string. But when I will go ahead and write that x variable inside integer function, this time I will receive a traceback error, because non-numeric characters cannot be converted into integers. And now we will move towards a video demonstration to understand that how we can manipulate the data type in our Python program. We are going to understand that how we can manipulate our data types and how we can change the data from one type to another. So for that, I'll just go ahead and let a variable x, and I will assign it a value of 45, which is an integer. In the next line, I will suppose another variable y, and I will assign it the value of data type of x. So type is a built-in function in Python library which is basically used to find the data type of variables like x. So everything that this function is going to retrieve will be stored in this new variable y. And in the next line, I will just go ahead and try to print out the value of y. I will save this file and I will try to run this program using Python. And you can see that here in the result, I am getting class integer because I stored an integer in this variable x. So let's just move ahead and put a floating point in this integer. For example, I'll just go ahead and write 0.4. Now this right here is a floating number. So this time type function will again retrieve the data type of the variable x, and that data type will be stored in variable y. And through this line, that class will be printed out in the answer. So I'll save this file again and I will run this file again. And you can see that the class has been changed from integer to float because this time our data had floating point in it. Now similarly, for example, I'll change my data from integer or float to a string. I am a string. I'll save this file again and I will execute this file again. You can see that the class has been changed from float to string because the data that was inside x is a string. Now we will just go ahead and try to convert our data type from one type to another. I will comment out these lines of code to disable them, and I will suppose a variable x and I will assign it a value of 5. I will let another variable y and I will use type functions to find the data type of x. I will again print out the variable y and I will run this file. And you can see that at this time it is showing me class as integer. This time I will comment out this line and I will suppose a variable y and I will use float function and I will put x inside it. Now this float function is a built-in function in the Python library which converts the integers into floating numbers. And in the next line I will try to print out my value of y. I will save this file and I will execute this file. Now you can see that the number has been changed from 5 to 5.0. Now what I'll do, I'll suppose another variable f and I will use type function to find the type of variable y. Because after changing x from integer to float, we stored its value in y. So this time we have to check the data type of y. And here I will print out f. I will save the file and I will execute this file. And you can see that the class has been changed from integer to float. So that is how we can convert our data type from one type to another. So what I'll do, I'll comment out all these code again, and in the new example I will use a string and I will put numeric values inside it. I will use another variable and I will store the value of data type of x inside it and I will print out the value of y. I will save this file and I will execute this file. You can see that right now it is showing me class as string. I will try to change the data type of this variable x. For that I will let another variable g and I will use int function to change the data type from string to integer. And I will put x inside it because I want to change the data type of x. And after that I want to store the data type of g inside y. And after that I want to print that y. Now I will save this file and I will execute this file. Now you can see that the class has been changed from string to integer. But what if we use non-numeric characters inside a string? For example, I am a string. This line here does not contain any numeric value. So let's see that if this int function still changes the data type of variable x or not. We will save this file and we will execute this file. Here you can see that it just gave us a traceback error because non-numeric characters cannot be converted into integer. Now we will see deeper inside building our own functions. So we define a function using def word, and then we use the name of the function, and then we place parentheses after the name of the function. And inside those parentheses, we write parameters. These parameters are absolutely optional. After that, we indent the body of the function. In other words, we use a colon at the end of the function defining statement, and after that we use appropriate spaces. Now, everything that we have done so far, this just created a function. It did not print out the results. So the example that we use, we have defined a function which is named as add, and it has two parameters. The first one is a and the second one is b. And in the body of that function, we are doing a process of adding both parameters and storing their value inside C. Now this is the body of the function, but it just do the processes. It does not execute the result at this point. A function does not execute itself. For example, I have assigned the value of 5 to the variable x. In the next line, I have tried to print out a word hello. And after that, I have defined a function called func. And in that function, I have tried to print out two lines. The first one is I am the body of the function, and the second one is I am a new string. And after that, I have tried to print out the value of x plus 2, which is supposed to be 7. Now, when I will go ahead and try to execute this program, the output will be as follows. It will show me hello and 7. Now everything that I just wrote inside my function isn't printed in the output, which means that it only does the process, it doesn't execute the result. To print the result, we have to call that function again. Now for example, after writing print x plus 2, in the next line, I am going to recall that function that I just defined previously. Now after executing this file again, the output will be hello 7, and after that I am the body of the function, and after that I am a new string. Now the function's body is printed after the result of x plus 2, which is 7, because we actually called that function there, which means that until you call your function again, the function will never be executed in the output. As we are saying these functions in detail, we have to understand that why we use these arguments inside of our functions. An argument is a value that we pass to a function as its input whenever we call that function. We use these arguments so we can direct the function to do different kind of work when we call it at different times. We can put the arguments in the parentheses after the name of the function. For example, here input is a function and everything that is written inside the parentheses is an argument. Now we have to understand the difference between parameters and arguments. Now consider the parameters as the general location where the multiple arguments can be stored. That parameter provides these arguments and access to the body of the function. A parameter is a variable which we use in the function definition. In other words, in the statement where we define our function, if you write a variable in the parentheses, then that variable is known as a parameter. On the other hand, whenever you call that function in a Python program, and during that calling, if you provide a value or a variable to that function, then that variable or value is known as an argument. Now that argument will then be stored into the parameter, and then the value that is stored inside the parameter will be used in the body of the function. For example, here we are using a variable lang as a parameter inside this function greet, and on the basis of that parameter, the flow of the body of the function is controlled. Now whenever we will call that function and we will assign a value to that function, for example, here in this line, I have recalled that function by using its name, and in the parentheses, I have provided a value that is en. This en is known as an argument. Now this argument will then be stored in lang parameter, and then that parameter will be used inside the body of the function. That's how arguments and parameters collaborate with each other in order to execute our functions in Python programming. Whenever we work with functions in Python, we also have to deal with the return values that those functions provide us as a result. Often a function will take its argument, do some computation, and then return a value which will be used as the value of the function call in the calling expression. Now by calling expression, I mean that whenever I will recall that function using the name of that function later in the program. Here calling expression is shown in green color and the return keyword is shown in orange color. Here I have defined a function and in that function I have written a line return hello. So whenever I will recall that function greet later in the program, the function will return the result hello. For example, I have written this line here. So in the place of greet, the function should return the result as hello. So the line that will be printed out should be hello John. You can see that the output is hello John because the result that was stored in that function will be returned using the return keyword. And the same goes for the second line. We can classify our functions into two different categories based on the return values. We can categorize these functions on the basis of these return values. The first category is a fruitful function. A fruitful function is the one that produces a result or return some value after executing the function. Whenever you write a return keyword at the end of your function, that return statement stops the function execution and then sends back the result of that function. For example, here you can see that I have written a couple lines of code. First of all, I have defined a function called greet and then I have provided that function a parameter called lang. Inside that function, I have used multiple conditional statements. And whatever value that will be stored in that parameter will then be checked by these conditional statements. And the output will depend upon the value that will be stored in that lang. So after defining this function, I will go ahead and recall that function in the next line. Here you can see that I have recalled that function and I have given it an argument that is en. Now that argument will be stored in the parameter lang of the function and then it will be checked by the conditional statements. As I have given an argument of en, so the first condition will not be satisfied and the function will move to the second conditional statement. You can see that this statement cannot be satisfied again. So after that, the function will move on the next condition, which is else. And when this condition will be satisfied, the function will return the result that is present in the body of that condition, which is hello. So as a result, the output will be hello John, and same goes for these two lines too. We can define more than one parameter in the function definition. We simply add more arguments when we call that function. In other words, if we are using multiple parameters, then whenever we will call that function, we will have to provide the same amount of arguments to that function too. For example, here I have defined a function named as add2. And in the parentheses, I have provided two parameters, which is a and b. In the body of that function, I am moving ahead and adding those two parameters and saving their value in the added variable. And after that, in the next line, I am returning the value of that variable added. So later in the program, whenever I will recall that function, just like I have done here, I will provide arguments to that function, which in this case are 3 and 5. Now that 3 will be saved in A and that 5 will be saved in B. After that, both values will be added, which will give the value of 8, and that 8 will be stored in variable added. After that, the value of added will be returned in the output. So whenever I will try to print out the value of x, I will get an output of 8. All the computation that yielded the answer of 8 was done in the function add2. The second type of the functions are non-fruitful functions. When a function does not return a value, we call it a void function. On the other hand, the functions that return values are fruitful functions. This means void functions are not fruitful. In chapter number 5, we will look towards the loops in Python. We will try to understand that how we can define and use our loops in our Python programs and what are the benefits that we can get from them. Unlike conditional statements, in which we have to choose the direction or the flow of program, loops deals with the repeated steps. In other words, the loops perform iterations. And those iterations have iteration variables that change each time through a loop. For every different iteration, the value of the iteration variable will be changed. Often these iteration variables go through a sequence of numbers which are also known as arrays. For example, here I have supposed a variable n and I have tried to assign the value of 5 to that variable. In the next line, I am trying to define a loop statement. In this case, we are using a while loop. And after that, I am trying to define the condition for that loop. In other words, if this condition is satisfied, then the loop will be executed. And as soon as the condition is falsified, the loop will be ignored. Now in our case, n is greater than 0. The value of n is 5 and 5 is obviously greater than 0. In that case, the program will move into the body of the loop and according to the first line, it will print out the value of n. And after that, it will move ahead and subtract 1 from the value of n. And the new value will be updated in the n variable. In the next step, the value of n is again checked whether it is greater or less than 0. Suppose the value of n is again greater than 0. Then the previous steps will again be repeated. The loop will print out the new value of n, and in the next step, 1 will again be subtracted from the new value of n. Now this newest value will again be updated in the variable n. And after that, it will again be checked whether the value is greater than 0 or not. And this way, these steps will be repeated over and over again until the value of n is equals or less than 0. Now suppose after some iterations the value of n has become 0, which falsifies the condition. Now in that case, the loop will be terminated and the program will jump to the next statement, which is print done. You can see that in the output for the first iteration the number 5 has been printed out, but in the next iteration the 5 has turned into 4 because we performed n-1 operation inside the loop. Now again this 4 is greater than 0, so in the next iteration 1 will again be subtracted from it, making it 3 from 4. And the same process will be performed again and again until the value of n becomes 0. And as soon as the value becomes 0, instead of continuing the process of that loop, the program will ignore that loop and print out done. There is another way of breaking out of a loop. The break statement ends the current loop and jumps to the statement immediately following the loop. In other words, suppose you have placed a break statement in the middle of your loop body. Now after executing that break statement, whatever that is after of that break statement will be ignored and the program will jump to the statement which is outside the loop. It is like a loop test that can happen anywhere in the body of the loop. Here I have used again an example of while loop. In the body of that loop, I am trying to get an input from the user in runtime. And after getting that input, I will store that input in a variable called line. After that, I have defined a conditional statement in which I will check that whether the input is done or not. If the input is done, then the program should break this loop. And after that, the print line will be ignored and the program will jump to the print done, which is outside of the loop. Now let's look at the output of this program. In the first line, the program is actually asking us to enter your word. Now, you can type any string you want other than done, and the program will print out the same string that you have typed in. But as soon as you type in done, the program gets into the conditional statement and breaks the loop, after which that done does not get printed out. Instead, the done which is outside the loop is printed out. And you can see that in this done we have an exclamation mark at the end. We can also finish an iteration with continue statement. The continue statement ends the current iteration and jumps to the top of the loop and start the next iteration. Here I have taken the same example of while loop that I previously used. But in this example, this time I have defined another conditional statement. In this conditional statement, I am trying to figure out the first character of the input, and I am trying to compare that character with hash. If the input starts with hash, then the program will proceed towards continue statement. If the input contains done, then the program will proceed towards break. And if all of these conditions are not satisfied, then the program will just go ahead and print out our input. Now let's just look at the output. In the first line, the program is actually asking us to enter your word. Here, for example, I have entered hello world, and the program has printed out the same hello world. But in the second time, I have typed in hash print. Now you can notice that the first character of this string is hash. As soon as the program sends this hash, it proceeds to the continue statement. So instead of printing out my input, the program breaks the loop and goes right back to the top of the loop. Now in the third example, I have typed in done. Now as soon as I type in done and hit enter, the condition written for done is satisfied and the program moves toward the break statement. Now just like continue statement, after the break statement, print line will not be executed. Instead, the program will get out of the loop and print done. Let's just see the video demonstration to understand the very basics of loops. Now first of all, we will see the use of break statement. I have used the same exact example that we discussed previously. In the first line, I am defining my loop, which is while loop. In the body of that loop, in the first line, I am trying to take the input from the user in runtime and then storing that input in the variable called line. Now in the next line, I am defining a conditional statement in which I am trying to figure out that whether the input contains string done or not. Now if the input contains done, then the loop should break itself, and instead of printing out this line, the program should jump on this line. Now to differentiate these both done from each other, I will enter these exclamation marks. So what I will do, I will save this program and I will try to execute it using Python. You can see that here it is asking us to enter a word. Let's suppose I will enter hello world, and you can see that it printed out the same string that I just typed in, and after that it is again asking me to enter the input. So for the clarification purposes, I will enter another string. For example, my name is John Doe, and I will hit enter, and you can see that the program again printed out the same string. This time I will go ahead and type out done, and I will hit enter, and you can see that instead of printing out this done, the program moved to the next string and printed out done exclamation marks. Now you can clearly understand that after I inserted done value in the input function, the program ignored this line, and instead of that it got out of that loop and printed out this line. So that's how this break statement actually works. Now we will understand the use of continue statement with the practical demonstration, of course. Now this is the exact same example that we discussed previously, but this is the extra part of the program that I just entered right now. So in this line right here, I have tried to define another conditional statement in which I'm trying to figure out the first character of the input, whether that first character is hash or not. So if this statement is satisfied and the first character of the input is hash, then the program will proceed towards continue, and after that it should proceed towards this print line. And if the second condition is satisfied, which is if the input is done, then the program should proceed towards this break statement, and after that it should move towards this line. But we have seen this previously, that instead of printing out this line, the program jumps to the outside of the loop and print this line. So what I'll do, I will save this program using Ctrl+S, and I will try to run this program again. The program is asking me to enter my input. So for example, I will type in hello world, and I will hit enter, and you can see that the program has printed out the same string that I just typed in. In the next step, what I'll do, I will write hash hello world. Now the first character of my input is hash. I will hit enter. So instead of printing out anything, the program just moved back to the top of the loop, which is this first line, right? So that's how this continue statement actually works. So what I'll do, I will just move ahead and type out done this time, and I will just go ahead and change this output here, and I will write finish instead of done, so we can differentiate between this output and this output. Okay, so I will execute. We had to save this file again and then execute the file. I will just go ahead and execute the same file, and this time I will type in done. I will hit enter, and you can see that the program did not bother to print out the string that I just typed in. Instead, it moved outside that loop and printed out this finish. So that is how the continue and the break statements in loops actually do work. We will discuss the difference between the working of continue and break statement so that we can understand and differentiate the outcome procedure of both statements. So whenever the continue statement is executed, everything that is after that statement inside the loop will be ignored, and the program will jump at the very top of the loop, which in this case is this line. But on the other hand, whenever the break statement gets executed, everything that is after that statement inside the loop will also get ignored. But this time, instead of going at the top of the loop, the program jumps out of the loop and executes the very first line of code that comes after that loop. In other words, continue statement asks the program to go to the start of the loop, and the break statement asks the program to leave the loop and execute whatever line of code that we have after that loop. In this lecture, we are going to have a quick overview about indefinite loops. The loops that we discussed in the previous lectures are further classified into two different types. The first type is indefinite loops, and the second one is the definite loops. While loops are called indefinite loops because they keep going until a logical condition becomes false. Now, if you can remember that in the previous lecture, when we used an example of a while loop, we had to define a condition for that. Until that condition was true, the loop performed all the iterations. But as soon as that condition was falsified, the loop was terminated and the program jumped right at the end of the code. So that is the reason that why we call these while loops indefinite loops. The loops we used were pretty easy, and it was relatively simple to examine that whether those loops will terminate or not depending upon the condition that we defined in those loops. But sometimes it is a little harder to be sure that if a loop will be terminated or not. In that case, our break and continue statements come into action. Here I am using the exact same example that I discussed in the previous lecture. You can see that in this line I have started a loop which is a while loop, and after that I have defined a condition for that, which is n is greater than 0. So until this condition is satisfied, everything that is written inside the body of this loop will be executed over and over again. But as soon as this condition is falsified, everything that is written inside the loop will be ignored and the loop will be terminated. And the program will jump right at the end of the code and execute this last line of the code, which is print done. So these are indefinite loops. Now is the time to go for the examples and understand that how these loops actually work. In this lecture, we will move ahead and perform several examples to understand the working of the loops. We will go through simple examples which will deal with the mechanism of loops, and even though these examples will be simple, the pattern applies to all kinds of loops. In other words, after performing these examples, you will understand the basic concept of loops, and that pattern and concept can be applied for complex and very long functionality programs too. Now, for loops are used to find or do something for each entry separately, and after that they update a variable, and that is called looping through a set. So here we have an example. In the first line, we want to print before, just to give it a starting point. There is no purpose of this line whatsoever. We are just defining a starting point for the program, and after that I have defined a for loop. After the for, I have written thing, and this thing here is an iteration variable, and you can remember that we can give any name to our variables. We can also write I, we can also write number, we can also write thing, or any other name you want to give to the variable. You can do that. And after the in operator, you want to write your set of data, which in this case is 9, 41, 12, 3, 74 and 13. Now in the body of this for loop, what I want to do is I want to print out every element that is present in the above set of data. And after going through the entire process of the loop, I want to print out the end as the finishing point of the program. So when we will execute this program, in the very first line, you can see that the before has been printed out, and after that for loop is being executed. Now this loop will go through all the elements inside the set of data, and it will start from the very first element, which is 9. So in the first iteration it will print out 9, and in the next iteration it will move towards the second element, which is 41, and that process will be repeated again and again until the last element, which is 13. Now after the 13, we don't have any element inside the set of data, so that for loop will be terminated and the last line print end will be executed. You can see that at the end of the output, end has been printed out. Earlier we said that for loops can be used to find elements in a set of data. So what if we want to use this for structure for finding the largest number present in the set of data? For that, this loop will obviously go through all the elements one by one, and then the loop will compare all those elements with each other to see that which one is the largest one. Now the loop will go through all the elements. It will start from 9, 41, 12 all the way to 13. We will define a reference number, and we will say that our first element is the reference number. If the new coming number is larger than the reference number, then the value of reference number will be updated, and the process will be repeated again and again until the very last element of the set of data. In this way, we can find out that which one is the largest number present inside the array of numbers. We will go ahead and perform this program inside of our Visual Studio Code to understand that how we can write our loop programs inside of our Python programming. Now we will see that how these loops actually work, and for the first time we will see for loop in action. And first of all, I will suppose a variable and I will assign a set of data to that variable. Let's suppose the data is 1, 34, 56, 67, 8 and 0. Now what I want to do, I want to use for loop to find out which one is the largest number present in this set of data. Right? For that, I will write for, and then I will write number. This is the variable that the for loop will use for the iterations. And after that we will write in operator and then x. And after that we want to place indentation and hit enter. So this statement right here is actually saying that look for each number in the variable x. So for loop will look for each number that is present inside the variable x, and it will do that one by one. So we want to find the largest number present inside our set of data. For that we need a reference number. Consider this as a starting point with which we will compare our numbers to see that whether they are larger as compared to that reference number or not. So for that I will just go ahead here and write reference number. This is a variable name and I will put 0 in it. So 0 is the smallest number which I am using as a starting point. Now what will I do? I will place a conditional statement here and I will ask to check whether the number that came from this set of data is greater than the reference number. If that's true, then update the value of reference number as the value of number. In other words, put the value of number which was greater than this reference number inside this reference number. It will update the value of reference number from 0 to the new number. After that I will get out of this if body, and after that I will get out of this for body. And here I will write print reference number. I will save this file and I will execute this program. You can see that it gave me the biggest number, which is 67. And you can see that in this set of data the biggest number was 67. We can also write print reference number here to see the updation of reference number for each iteration. And I will write the largest number is. I will save this program and I will execute this program. And you can see that for the first iteration it compared 0 with 1 and it saw that this new number 1 is greater than 0. So it updated the reference number value to 1 and printed out that value. And in the next iteration it compared this 1 which was already present in the reference number to the next coming number which was 34. And after comparing them it understood that 34 was greater than 1. Then again went ahead and updated the value of reference number. And after that it printed out that reference number which is 34. In this way the process is repeated until the last element of the set of data was iterated through. And at the end of this set of data, the for loop was terminated and the biggest value of the reference number was then transferred to the last line of code, which is print the largest number is reference number. In this lecture, we are going to move ahead and try to understand that what are loop operations. In other words, we will try to learn that what kind of operations we can perform inside of our loops. And we will learn all of that by using several examples. So as a first example, I'm going to discuss the counting in a loop. In other words, we will try to count the number of iterations that will be performed in a certain loop. So to count how many times we have executed a loop, we introduce a counter variable that starts at 0, which means that at the very beginning of the program, that counter variable will have a value of 0 in it. And then we will add 1 to it each time we will perform an iteration. So in the first line of this program, I have defined a variable by name of val. Now this variable is actually a counter variable which has value of 0. And after that, I have tried to print out before and then the value of val. So this line right here just plays the role of a starting point. In the next step, I'm going to define my loop, which is a for loop, and in that loop, number is the iteration variable. Now that iteration variable will have different values in different iterations. Here in is an operator which will help my iteration variable to look inside the set of data. Now in the body of this loop, in the first line, when the iteration variable looks for the first item in the set of data, then it will add 1 to the previous value of the val, which was initially 0. And the result of this operation will be updated into the same variable val. In the next line, it will print out the number of iteration corresponding to the number which is present inside the set of data. Now, for example, you can see that in the output, 1 has been printed out against 9. Because 9 is the first entry inside this set of data. So that 9 will be printed out in the first iteration. That's why 1 has been written against 9. Now this whole process will be performed again and again until all of that data is covered through the loop. Now as soon as the last entry is processed through that loop, the for loop will be terminated and the program will jump to the last line, which is after val. Now at the end of this program, the value of val will be the number of iterations that has been already passed. So as the result, 6 will be printed out because there are 6 entries inside the set of data. So the loop iterated for 6 times. We can also perform summing inside the loop. Now this summing in a loop means that summing all the entries that are present inside the set of data. Now to add up all the values that we have inside the loop, we introduce a sum variable that starts at 0, just like we did with the counter variable in the previous slide. And then we add the value to the sum each time through the loop. In other words, inside every iteration, we will add the next value to the previous value. Here, val is a sum variable, which is starting from 0. And after that, I have printed before and the value of val just for the sake of defining my starting point. And after that, I have defined my loop, which is a for loop again, and number is the iteration variable. In is an operator that will help my iteration variable to look inside the set of data. Now in the body of the loop, what's going to happen is the value that is stored inside the iteration variable will be added into the value of val, which is initially 0. And the result of this operation will be updated in the same variable val. So for example, for the first iteration, the first entry of the data is 9 and the previous value of val was 0. So 0 plus 9, the answer should be 9. And you can see that in the output, 9 has been printed out against 9. Here the 9 which is in blue is the result of val which we got after adding both numbers. And the 9 in the red is actually the entry that is present inside the set of data. Now in the second iteration, the next entry will be added into the previous value of val, which is now 9. And we will get 9 plus 41 is equal to 50. So as a result, for the second iteration, 50 will be printed out against 41. And the same process will be performed again and again until the loop finishes its task. And after that, at the end, the total sum of all the entries will be printed out against after. So first of all, we will look ahead and try to make a program that will count the number of iterations inside a loop. For that, I have to define a variable, which is actually a counter variable, which starts from 0 and then it will add 1 in itself for each of the iteration that it will pass through. So suppose that variable is counter variable. You can use any name of the variable you want because at the end of the day it is just a variable. So I will assign the value of 0 to that variable, and after that I will write a loop and I will write an iteration variable, and again you can use any name you want. You can write number, you can use any type of variable name that you want. So let's just move ahead and type in number, and then I will write in operator, and after that I will write my set of data, which is 1, 2, 45, 67, 8, 34. I think this should be enough. And after that I will type in colon and I will hit enter, and the Python will add a certain amount of spaces, which are also called indentations. And here I will define the body of this loop. So what I will do, I will write my counter variable name again, and I will add 1 into that variable each time this loop is executed. So this 1 will be added into the previous value of the counter, and that resulting value will be added into the counter variable. And after that, what I will do, I will try to print out the counter value for each of the iteration, and also the entry which will be stored in this iteration variable, right? So as the result of this line right here, the number of the iteration will be printed out, and along with that, the entry that is stored in the iteration variable for that particular iteration will also be printed out. And after that, I will get out of the body of this for loop, and I will try to print out number of iterations are. And here I will print out the value of this counter variable, which is actually storing the number of iterations. So I will type in counter underscore variable, and I will save this file. And after that, I will try to execute this file using Python. I will hit enter, and you can see that for the first iteration, the entry is 1, and for that entry, the number of iteration is also 1. And for the second iteration, the entry is 2, and hence the number of iteration is also 2. For the next iteration, the entry is 45. So here 3 is printed out as the number of iteration, and 45 is the entry that is being processed in that particular iteration. And at the end of this program, number of iterations are printed out, which are 6. You can see that here we have 6 entries here. So for loop will run 6 times, and the number of iterations will be 6. So that is how we can count the number of elements inside a set of data by actually counting the number of iterations of the for loop. In this video, we will try to make a program that will add all the entries that are present inside a set of data, which is also called an array. So for that, what I'll do, I will just go ahead and create a variable, which is a sum variable, and I will assign a value of 0 to that. Now, you can name anything to this variable. I just gave it the name of sum because it will be easier for me to remember that. And this variable starts from 0, which means that initially the value which is inside this variable is 0. And after each iteration, that value will be changed according to the data that we are going to process in our program, right? So let's just also go ahead and try to count the number of iterations of this program too. And for that, I will define another variable, which is a counter variable, just like in the previous video, and I will assign a value of 0 to that variable. Now in the next step, I will define my for loop, and I will use my iteration variable as number, and I will write my in operator, and after that I will write my data, which is 1, 3, 56, 67, 90, and I think this should be enough. And after that, I will go ahead and type in a colon, and I will hit enter, and the Python will add indentation at the start of this line. And now I will just go ahead and type in the body of this loop. So first of all, what I will do, I will try to find the number of iterations, and for that I will write this counter variable, and I will try to update the value of this counter variable after each new iteration. So for that, what I'll do, I will write this variable again, and I will add 1 into it, just like we did in the previous lecture. So this line right here means that after each iteration, 1 will be added into the previous value of the counter, and that's how this variable will store the value of the current iteration. Now the main thing that we want to do in our program was to sum all the values inside the entry. For that, I will update the value of sum, and what I'll do, I will write sum and I will add number in it. So we need to understand that what this line is actually doing. For the very first iteration, the value in the sum is 0 because we just defined that this value of sum should be 0. So for the first iteration, the value of this iteration variable, which will be 1, is going to be added in the value of sum, which is 0. So the answer that we will get from 0 plus 1 is equal to 1. That answer will be updated in this variable. And what I will do, I will go ahead and try to print out the value of the counter variable, and along with that I want to print out the value of sum. So this variable right here will print the number of iteration that is going on. What I will do, I will just go ahead and get out of this loop, and I will write the sum of all the entries is, and after that I will write sum, because at the end of this program the result that we will get after adding all the entries of this array will be stored in this sum. So we will save this program, and after that we will try to execute this program. Now you can see that in the first iteration the number that was stored in the iteration variable is 1. So this is the first entry of our array, and because this is the first entry, so the iteration will be the first. Now the second element in our array is 3. So for the second iteration, the answer of the sum variable should be 1 plus 3, which is 4. And you can see that here 4 has been printed out. And this process is being done in the second iteration. So along with that, 2 has been printed out. Similarly, 56 is the third entry of this array. So in the third iteration, the sum should contain the answer of adding all these 3 elements, which should be 60. So you can see that in the third iteration, 6 has been printed out along with the number of iteration, which is 3. So this process will be repeated again and again until all of this array is being processed. And at the end of this program, we will print out this line which states the sum of all the entries is, and after that we will print out the actual sum of all the entries that we got after doing our operation, which is 217, right? So what if we want to find the average? Finding the average. To find the average, we have to follow up this formula in which I have to sum all the entries that are present in the array, and then I want to divide that sum on the number of entries that array contains, right? So here number of entries can be shown by this counter variable, because the number of entries will be same as the counter which is counting the number of iterations. So what we will do, we will try to print out a string which states the average of all the numbers is, and after that what we will do, we will divide this sum by the number of elements which are stored in this variable. So we will just go ahead and write sum divided by counter variable, and we will save this program. We will again execute the program. Now you can see that after this line which shows the sum of all the entries, this new line has been printed out which states the average of all the numbers is 43.3. So that is how you can perform your operations inside of loops. So that is it for this video. In the next part of this course, I will discuss the data structures in Python in detail for beginners. So if you like this video, if you learned something significant from this video, do tell me by posting in the comment section of this video. And also consider subscribing to my YouTube channel for upcoming videos like this.